the waiting times between a subway departure schedule and the arrival of a passenger are uniformly distributed between 0 and 5 minutes. Find the probability that a randomly selected passenger has a waiting time that's less than 1.75 minutes. Now, a continuous random variable has a uniform distribution if its values are spread evenly over the range of possibilities. So the graph of a uniform distribution results in a rectangular shape. So let's talk about that rectangular shape and let's draw it out. So here we're going to draw it out, okay? So we know that this is going to represent, or the vertical axis is the probability, and the x-axis or the horizontal axis is x, which is the time in minutes. Okay, so now that we have that, okay, now for a density curve to be a graph of a continuous probability distribution, it must have a total area under the curve equal to 1, and the curve cannot fall below the x-axis. So this is what we're going to have, a rectangular shape, and we know that the area of this entire thing is going to equal 1. So the area is equal to 1. Okay, now the length of the uniform distribution is the difference between the maximum and the minimum values. So it's going between 0 and 5 minutes. Okay, so if it's in between 0 and 5 minutes, we know that we have 1, we have 2, we have 3, and then 4, and then there's 5. Okay, so that's the first thing that we need to do, is find the length of the uniform distribution. So if we take 5 and then subtract 0, that's going to give us 5 minutes. Now in step number 3, what we want to do is, since the uniform distribution is rectangular and it has a length of 5 and an area of 1, we want to determine the height of the uniform distribution. Okay, and then rounding that to 2 decimal places. So we're going to take the area, okay, and then we're going to divide it by that length to find the height. So the area is 1, and then we're going to divide that by 5. Well, what do we know about 1 over 5? Well, 1/5 is equal to 0.20. So therefore, that's going to represent the height. So up here, here's the height, 0.20. Okay, now the question is asking the following. Okay, so the question is saying that we want to find out, okay, the probability that a randomly selected passenger has a waiting time less than 1.75 minutes. Now we know that 1.75 is in between 1 and 2. And so 1.75 is probably located somewhere right there at 1.75. Okay, so what we're going to do is we're going to draw a line up here, okay, and then we're going to shade everything that's below that up until the value of 0. So let's go ahead and do that. So this is going to represent, okay, the area, okay, that is the waiting time that's less than 1.75 minutes. Okay, so now that we have that, what we want to do is, because the total area under the curve equals to 1, there is a correspondence between area and probability, which is what we see here. Okay, and therefore the desired probability can be found by determining the area of this region. Okay, so to find this area of the region, we need to know what is the length of the shaded region. So we can see here that the length of the shaded region is 1.75. And then we also need to determine what is the height of the shaded region. And the height is 0.20. Okay, so let's go ahead and do that. So now in step number 4, okay, what we want to be able to find now is the probability of when it is less than 1.75 minutes. So that's equal to the length of the shaded region times the height of the shaded region. So again, we know that the length is 1.75 and we know that the height is 0.20. So let's go ahead and then multiply that out. So we're going to take 1.75, multiply that by 0.20, and then we get 0.35. So this is going to be considered the area or the probability. So that 0.35 is going to be the probability that a randomly selected passenger has a waiting time that's less than 1.75 minutes. Let's go ahead and put that answer in, 0.35, and there is our answer.